All right, so we're going to solve log and exponential equations today. Something that will be mostly review for all of you, and I'll give you honor. And the steps are, we're going to solve for the exponential first, and then we will, if we can, find the same base on both sides and then equate the exponents. And if we can't, then we have to take the natural log of both sides. Okay? Or we can take whatever log we want of both sides. All right, but let's start here. The exponential is 1/4 to the x over 3. So I'm going to divide both sides by 32. So we get 1/4 to the x over 3 equals 2 over 32. I can simplify that to, yes, 1 over 16, which I can get the same base here. 1 over 4 to the x over 3 equals 1 over 4 to the second. So then we can equate the exponents here and say x over 3 equals 2, and so x can equal, or will equal 6. That's not too bad? Nope. All right, next one. Now, I put a very large dot here to signify multiplication, and our 3 and 4 are different bases here, correct? The exponent on the 3 is 1, and 4 has an exponent of x over 2. We cannot multiply these together because they have different bases, okay? And so we must divide by 3 first. So we're going to get 4 to the x over 2 equals 32. Good. Now, I can get the same base here again on both sides, but it's not going to be 4. It's going to be 2. So this will be 2 squared to the x over 2 equals 2 to the 5th. And so when I multiply these exponents, because when you raise power to a power, you multiply. And then this will be 2 to the x equals 2 to the 5th, making x equal to 5. Nice. Okay. You know, it's nice plus of these.
I love it.
All right, moving right along. We're going to divide by 3. And this one will be 5 to the negative x over 4 equals 5. So we just say negative x over 4 equals
1.
The invisible 1 on the other side. So then x equals negative 4. I figured we'd start off really easy. Do we have that?
Yep.
Moving right along. Now, this is a log equation. This is a log equation, log equal to a number. And where is the x? It's inside the log's argument, so we need to set it free. We have to exponentiate, you're right. And why are we going to exponentiate? Because that's the inverse operation. Okay, so let's exponentiate here. We're going to say, oh wait, why am I'm going to use, instead of e, I'm sorry, I'm seeing, this is 2. Right, the log and the log base 2 and the 2 cancel because those are inverse operations. And so then I get x equals 2 to the 5th and x equals 32. Okay? I have one down here. Bring it up for ease. This is a nested log. A lot of logs here. Okay, so this is still a log equal to a number. And so we are going to exponentiate. We're going to exponentiate from the outside in. So the external base is here 2. So I'm going to raise 2 to both sides there. And the log base 2's cancel. And then I'm left with log base 4 of x equals 2 to the first, which is just 2. And then last one, we're going to exponentiate here with base 4. These cancel and we get x equals 4 squared or 16. So if you had one of these on the test that was 5 logs nested together, would you freak out?
No.
No, you just go one at a time. You have to exponentiate
A lot.
a lot of times, but you get there, okay? Now, this is another type of equation where you might have a log equal a log, but I have a coefficient. And you can't exponentiate if you have something in the path between the log and the number you're going to exponentiate with. So I have to do something with the 2/3 first. You have to raise it up. So I'm going to take this and bring it up to the top here. And so this is log base b of x squared plus 7 equals log base b of 64 to the 2/3. And we can actually simplify that, right? 64 to the 2/3 is the cube root of 64, which is 4 squared, which is 16. So we can say that this is equal to log base b of 16. Log base b of. Now, we have to do the inverse operation here, so we're going to exponentiate and that causes these to go away because they're inverse operations. And then I get x squared plus 7 equals 16. X squared equals 9. X equals plus or minus 3. Now, I caution you here, you can't take the log of what kind of number? A negative number. But this might be okay because if we go back to the original, it's squared. So are we taking, even if it wasn't squared, if it was something less than 7, you'd still be okay. All right, so this is okay. We don't have any extraneous solutions. So when you're solving log equations, you should check for extraneous solutions. And extraneous solutions occur when your argument is equal to 0 or less. All right? Moving right along. You have a prayer of getting the same base here.
Yes.
I mean, you're in a Catholic school. Who knows? Miracles could happen, but not here.
No.
Right? So we can take the log of both sides. Now, we have the log base something, or we have the ln base something, and which has fewer letters? The ln. Naturally, we'll use that one. Oh, boo, I know. So I'm going to take the log of both sides, the natural log. Will you get the same answer if you use a different base? The answer is yes. Okay, so what can I do with this x?
Bring it out.
Bring that out in front. So that'll come down in front, and I get x times the natural log of 0.98 equals the natural log of 1.6. Solving for x, we'll get the natural log of 1.6 divided by the natural log of 0.98. So before we stick this in the calculator, what kind of number are we going to get here?
Positive. Negative.
Well, let's think about the log graph really quickly because I like to bring us back to tying things together with the graph. This is the natural log function. And between 0 and 1, what kind of number are you going to get? The log of a number between 0 and 1 is negative. So this is going to be a positive number in the numerator and a negative number below. So somebody give me this decimal, please. I'm sorry, negative 23.26.
Yep.
Okay. So I want us to be thinking about what kind of numbers we'll have, positive or negative. All right? Next one.
On 7.
Yes, we can subtract 7 from both sides. I like it. So this is negative 3 e to the negative x equals negative 5 if I subtract 7. Divide by negative 3, we get e to the negative x equals 5 over 3. take the natural log of both sides.
Log the cancel.
I'm going to bring the negative x down here, and I'll do this one step here first, just to show everybody what we're doing. The natural log of e
There.
naturally is 1. So then this is negative x equals the natural log of 5 over 3, and that's x equals negative natural log of 5 over 3. Now this is the exact answer here. The approximate. Now, before we plug it in the calculator, we know the natural log of 5 over 3 is a positive number, right? And so what do we get here? Negative
25, 1, 2.
25,
1,
1.
1,
1.
1. Now, if you don't want to show this step and you can just go to negative x here, that's okay. I'm just showing this for notes purposes. Okay? Moving right along. This is almost a log equal a number, except it's not. What would you like to do first? Subtract 3, so we get negative log of x plus 2 equals 2. Good. I can't exponentiate yet. Why? Because there's a negative in front of the log. So this would be log of x plus 2 equals negative 2. And now we're going to exponentiate. And what base?
10.
Good, because that's the common log if it's not shown. And so then, since these are opposite or inverse operations, those on the left side, the log and the 10 go away. We get x plus 2 equals, what's 10 to the negative 2?
1 over 100.
You guys are like on today, it's great. So 1 over 100. So this is going to be x equals 1 over 100 minus 2, which would be 200 over 100, which would be negative 199 over 100. Got it?
Yep.
You're doing great. What do we do here?
It's 2. The 2 out.
Right, both sides should be.
This is dangerous, this problem. You need a little star by it. It's tricky. If you bring the 2 down, let's think about it.
Would that have to be
If I bring the 2 down, that's 2 natural log of x equals 4. You can divide by 2,
ln of x equals 2?
right? And then you exponentiate and you get e squared, correct?
Yes.
But what plus or minus e squared work here? Yeah. Okay, so what I'm going to do is show you that, yes, you can bring the 2 down here. This is the way not to do it. I'll say not this way. Bring down the 2, and we say, is it wrong to bring down the 2? No, I mean, with the properties of logs, you can do that. That's not a problem. What happens in solving this is now I divide by 2, I get ln x equals 2, and then I exponentiate with base e. And then these cancel out because they're opposite operations, and we get x equals e to the second. Okay? But what happens if we, this is the way, right? This way. I'm going to put big letters. What happens here if we take natural log of x squared equals 4 and we exponentiate it right away? We get
Squared equals e.
x squared equals e to the 4th, and x will equal then plus or minus
Squared.
e squared. Which the negative works in here. Now let's think about what the graph of this looks like, you know, because I like to think graphically, and I want you guys to start thinking graphically. If you're graphing ln of x squared, we're we're gonna not look at the calculator, right? We're just gonna graph this. It's gonna look like this side, it's gonna probably look like this, but can I put in negative numbers now with this being squared, the argument?
Yeah.
So what's gonna happen is it's gonna be reflected here. And I'm not gonna do this to scale, because clearly it might not be. God bless you. What happens if I let y equal 4? Oops.
You'll get a negative and positive.
You get a negative and positive answer here, graphically. You see what's happening?
Yes.
And this is going to be e squared, and this would then obviously be negative e squared. Okay, so this is a danger because your original will allow you to plug in what kind of numbers? Plus or minus. So watch it. If this is an even exponent, exponentiate it before you bring down any exponents. Okay? So what did we do here? We lost a solution. Lost a possible solution. All right, moving on. This was everybody's favorite this morning.
Really? Oh, wait.
No. That's a false good.
Okay.
So what are we going to do first? We're going to multiply by 2, right? Because we want to get rid of the denominator. And we'll say 2 to the x plus 2 to the negative x equals 6.
Okay.
Now we can solve this graphically. We can put it in the calculator and put 1 on the left side and y1 and the other and y2. We get a solution. Okay, but algebraically, we need to figure it out. So I'm going to move the 6 over. So we'll get 2 to the x plus 2 to the negative x minus 6 equals 0. And so I would like us to factor out the 2 to the negative x, because something nice is going to happen when we do that. You know, it doesn't feel like it's going to be nice in the beginning here. So I factor out a 2 to the negative x. What's standing in the 2 to the negative x spot?
1.
Everybody agree that that's 1?
Yeah.
Yeah, that's good news. Now, if I'm going to factor 2x minus 4 and factor a 2 out here, this will be x minus 2. What did I do to this 4 to get the 2? You divide it. So then I'm going to say this will be 2 to the x over 2 to the negative x, and then minus 6 over 2 to the negative x. But when you have a negative exponent in the denominator,
1, you can smooth it.
right, or you can subtract the exponents, right? So it would be x minus a minus x, which is 2x. So this would be 2 to the 2x. Now I'm going to put them in a different order. Minus 6 times 2 to the x. Good, because if it's parked in the wrong space here, down here, because it's got a negative exponent, it really belongs to the numerator. Plus 1.
Wait, what?
I'm sorry, what?
Never mind.
Okay. Does this look like something maybe might be? It looks kind of quadratic. What's x here? If you were thinking about it in the typical sense, quadratically, it would be x squared minus 6x plus. Right. So in your mind, could you rewrite this similarly to like 2 to the x quantity squared minus 6 times 2 to the x plus 1 equals 0? Could you do that?
Yeah.
Right? And then if we were solving this ax squared plus bx plus c, setting it equal to 0, we'd use the quadratic formula, which would be x equals So what are we going to do instead of having x equals here?
Yeah.
It would be 2 to the x equals. And yes, we could use u sub, but I challenge you to not need u.
I got it.
You got it?
Okay.
So what, it's going to be 2 to the x equals, well, what is a here? Let's think about it. What's a? 1, good. B is -6. C is 1. So now we're going to use the quadratic formula to solve this part, and then we'll talk about the 2 to the negative x out here. So it's 2 to the x equals the opposite of b, which would be 6 plus or minus the square root of 36 minus 4 times 1 times 1 all over 2a, which is just 2. So this is 2 to the x equals 3 plus or minus the square root of 32, which is 16 times 2. 4 root 2 over 2, which equals 3 plus or minus 2 root 2. So I have two equations here. I have 2 to the x equals 3 plus 2 root 2. And then I have 2 to the x equals 3 minus 2 root 2. How do we solve those? Naturally, we should take the natural log of both sides. And I get x times the natural log of 2 equals the natural log of 3 plus 2 root 2. X equals the natural log of 3 plus 2 root 2 all over the natural log of 2, and that's going to give us a number. And then this one is going to be the same answer, except it's going to have a negative sign. So x natural log of 2 equals natural log of 3 minus 2 root 2. X equals natural log of 3 minus 2 root 2 over natural log of 2. And so if we get x equals, somebody give me a beautiful number here to the plus 1.
2.54.
Good, 2.54. Now, my only concern here is now, is that 2 root 2, because it's negative, that's gonna, are we gonna have a negative number here in the log? So, 2, or root 2 is 1.414, so 2 times that'll be 2.828, so I think we're gonna be okay. So what do we get when you do this? Yeah, I think it's going to be pretty symmetrical here. Yeah. Which is nice. Okay, now, those are our two answers, and then we have one other factor to consider, which is 2 to the negative x equals 0. What happens here? We take the log of both sides, and I get ln2. I'm running out of space. Wait, can I take the log of 0?
1. No.
No. Think of the graph here. 2 to the negative x. What does it look like? 2 to the negative x. That's the same as 1/2 to the, yes, that's right. Pam, you're right. Here we go. Is that ever 0?
Nope.
Not in a million years. So this is no solution. And I mean in a million years because, right, it's going to keep going, and closer, but never get there. It's like it's taunting 0. We're never going to make it. Okay? Got it?
Got it.
Next. Sometimes you don't have to factor out a negative like an exponential with a negative exponent. Sometimes you can just factor. Two e to the x and e to the x.
Plus 3 next to it, yeah.
Okay, plus 3 and,
No, on the other.
oh, we're different.
Then minus 1. But plus 3 is 2 e to the x minus 1 and e to the x.
Plus 3 and
Minus
minus 1. Okay, gotcha. All right, so let's talk about this one. This is 2e to the x minus 1 equals 0. 2e to the x equals 1. E to the x equals 1/2. How do we solve that? Natural log, so we're going to say natural log of this, natural log of this. We got 5 minutes. And we have the longest bells in history. X equals the natural log of 1/2, which you could expand and say natural log of 1 minus natural log of 2, because it's division. And the natural log of 1 is 0. So x equals negative natural log of 2. And before you ask on a test, I would accept either natural log of 1/2 or negative ln of 2. Okay, so don't freak out about that. All right, what about the other side here? We get e to the x plus 3 equals 0. E to the x equals negative 3. Mr. Turco shaking his head, no way, Jose.
You can't take the natural log and negative.
For all time, guess what you'll do. Okay, what happens here? E to the x looks like this. Negative 3 is way down here. Do they ever intersect? No, and if you wanted to algebraically prove it to yourself, can you take the natural log of the negative number? And the answer is no. So this is no solution on this side. We have only one answer, which is negative ln of 2. Logistics, we've done this already. What do? Solve for x, cross multiply. So we get 150 times 1 plus 95 e to the negative 0.6 x equals 400, and you guys did pretty well on the quiz. So 1 plus 95, I'm going to divide by 150, and I'm going to get rid of one of my zeros, if that's all right with you. And then I'm going to subtract 1. 95 e to the negative 0.6x equals 40 over 15 minus 1, and then divide by 95 or multiply by 1 over 95. You notice I'm not simplifying, so I'm going to just put it in the calculator. And then we take the natural log all of this, and we get negative 0.6x equals the natural log of 1 over 95 times 40 over 15 minus 1, close parentheses, and then divide by negative 0.6. Very nice. I don't know if anybody's gotten ahead of us and done that, but
6.74.
0.74?
6.74.
6.74, thank you. Questions on that? What do? We just cross multiply and get the x all by itself. Looks messy, but not too bad. Here, I have 2 logs on one side, so I need to condense first and get a log equal to a number. So what do I have to do with 1/2? Raise it up to the top here. And I get log of x minus the log of, and this will be the square root of x plus 4, right? Because it's the 1/2 equals 1, but I'm subtracting on the left. So when you're
You can.
right, so this would be log of x over the square root of x plus 4 equals 1. And now I have a log equal to a number, so the strategy is exponentiate with base 10. Very nice. With base 10, And the left side of log and the 10 cancel, and then we're left with x over the square root of x plus 4 equals 10. Now we're going to have to cross multiply. 10 root x plus 4 equals x. And at this moment, I'd square it right here. I mean, I like squaring 10. We get 100 times x plus 4. Now, when you square something, what do you increase the risk of? Some extraneous solution, so we have to be on the lookout for that. And we'll finish after lunch. Hopefully, you'll be pretty quick.